I think without further ado, we can get started, right? So Sylvia Muller and I, Matthew Kennedy, we're going to talk to you about workflow wizardry and best practices for your spreadsheet workflows. And I'm going to hand over to Sylvia.
Thank you so much, Matt. Hi, everyone. Lovely to see everyone's faces here this morning. I'm very excited to talk to you about spreadsheets. Anyone who was in our hackathon session yesterday will have seen some of this already, but I'm going to go into greater detail today. So I'd like to start with some problem statements. Spreadsheet building is really fun. At least I think it's really fun. It's creative, but it's kind of computery, and I think it's really interesting, but it is really laborious. It takes a lot of time. We're building the same tables over and over again in every workflow we make, and it takes some time. Having all your spreadsheets built from scratch as well, and being built by lots of different people, means that you're going to have a lot of variation in your spreadsheets. This can make things difficult to maintain and update as you're trying to add new things to them. And finally, our existing spreadsheets, although built really well, they could do with a refresh, let's face it. We wanted something that looked cleaner, that was more user-friendly, and with an updated style guide. To this end, I would like to introduce you to Eve. Eve is our common ancestor spreadsheet. I'll pause for a laugh, thank you. Eve is the starting point for all of our spreadsheets. We've used this template to build all of our new accelerator workflows and some of our exemplar workflows. Eve is a collection of 96 individual tables that covers the basic functionality that you'll have in all of your spreadsheets. It's got control tables, exception tables, it's got some basic inventory tables in there, we've got some result transform tables, and some interaction with the data engine as well. Eve has been designed to be usable by builders of all different skill levels. You're going to need some degree of knowledge of how to build spreadsheets regardless, but the way we've built Eve has really taken into consideration how we can help builders. We've got a builder checklist, and we've got comments on a lot of our tables to make sure that you understand what each table is there for. Using Eve has dramatically reduced the time it takes us to build an end-to-end workflow from weeks to days. And I'm not just picking days out here. We did a test. We had someone build a spreadsheet using Eve. It took about 10 hours. We had someone build the same spreadsheet from an empty spreadsheet, and I think it took over 2 weeks. It has, I cannot emphasize enough how quickly it is now using this base template that we've made. And what I'd like to do now is I'd like to take you through some of the functions that we've got within it. So although Eve is not built to be a standalone spreadsheet, it does have front-end functions that you can see as an end user. So if you were to open Eve up in the web editor, you would see that we've got 4 tabs based over 2 perspectives. The first tab is our introduction tab. The introduction tab has a few tables on it. It's got one table for record metadata. This is smart fill information pulled in from the hierarchy to show you where you are, where this spreadsheet sits within your system. We also have test-specific inventory tables. Now, we've changed how we build inventory tables and how we display data from the inventory in our inventory tables. But our test-specific inventory tables are there to show you specific details of specific things that you're going to use within your experiment. And I'm talking the cultures that you'll be growing, the process intermediates that you're filtering, the products that you're using. Not the everyday things that you use in science, but your actual experimental things. The next tab is our inventory tab. In the inventory tab, we've got tables for general equipment and general materials. Again, these aren't constrained to be specific types of item. We pull in all the basic inventory details like name, status, location, and any expiry dates. But because we now can see any information from the inventory really easily by hovering over an item ID and using the inventory slide out panel, we don't really need to pull in all the specific details anymore. We can just show you the basic things. Because let's face it, when we're using basic inventory details within a spreadsheet, we're looking for the genealogical links. That's what we're looking for. The last table in this tab is the experimental specific reagents tab, or the preparations table. Here we can make specific items for your experiment. If you're just mixing up some media, you don't want to go through a full reagent preparation process, we can just record the creation of that thing within your workflow. The third tab is a reviewer summary tab. This shows you all the incomplete mandatory fields that are left within your workflow and any exceptions that have been flagged. Now, I will talk more about exceptions in a moment. We have changed quite a lot about them. What this tab is there for is to remind you of anything that might have gone wrong within your process, because often if you're having a problem in a spreadsheet, it's likely that you've missed a mandatory field somewhere, and that one field hasn't been filled out is causing problems downstream. So that's what our incomplete mandatory fields do. The very last tab and the very last perspective is the reconciliation one. This allows you to update any materials or samples that you've used within your experiment, and that is ones that have been queried in or ones that have been created. It allows you to update the status, the location, and any volumes that you've used of those items. And it's really easy to update this table if you want to add different types of thing. It's all there in the functionality already. And what you'll do is you'll put your user-facing tables kind of right here. Now, if you were to open up the spreadsheet in Web Editor, this is what you'd see. I'm really sorry, I know this is very blurry, but if you want to see a better image, come find me later on, I'll give you a live demo. Oh, that really is very blurry. What this is trying desperately to show is the introduction tab. Let's see if I can use this. Ha! This is our metadata table up here. It just pulls in things from SmartFill. Down here, we've got a test materials table and a test samples table. Now, I can hear you say, Sylvia, we're not using samples in our experiments. Don't worry, you can just hide this table. It doesn't matter. Eve is there to be modified for you. You can update these tables to be specific for any type of inventory item that you're using. We often update them to read in cultures or process intermediates, but it really depends on the thing that you're using in your experiment. The next tab is our inventory tab. So up here, I've got a equipment table for all your any types of equipment that you'll use. We've got a materials table for any materials that you'll use. And down here, we've got our preparations table where I will specify the creation of a thing by combining different components and specifying how big the thing is, the volume, and when it goes out of date. So if it was populated, you'd see that I have additional rows in these tables as needed. Here in this table, I've got exceptions flagging because the functionality is all built in. So we've got 2 exceptions here that say that the status of the thing I've used is not available, so that might be a problem. And down here, I've got a preparation that I've made. I think I've combined an analyte and a culture, so I'm not sure what I'm making here. But I can see that it goes out of date in 100 days, and that will all be there within the inventory system for me. The reviewer summary tab at the top, I've got a little table that's a quick overview of this is what your experiment is, this is how many incomplete mandatory fields we have, and this is how many exceptions have been flagged. These are my mandatory incomplete fields, and I've got a little link there so that I can click on that link and it will take me directly to the table in a perspective that has an incomplete mandatory field. So you don't have to go back and go, oh, where is that table? I don't remember it. There's a link. You don't need to worry about it. Exceptions table down here shows us the location that the exception was flagged in. Again, we've got a link to that. The inventory object or the item ID of the thing that has triggered the exception, what field the exception was triggered in, and what the actual exception is. And we can also put comments on each exception if needed, and we can also resolve the exceptions if needed. That last tab is the inventory reconciliation tab. So here are the materials that I've used within this process and the one I created as well. I can update the status, I can update the value, and I can update the location. Now, if you were to open up the back end of Eve, you'll see that we've got a bunch of folders in a nice organized structure. We've tried to be really organized with how we've built it because I know as you go along building things, things can get a bit messy. So we've tried to give you as tidy a starting point as possible. We've got 3 very small folders at the top. These are developer instructions, the display pages, and the web editor for tables. We've also got user tables all bunched together under little folders. So for each canvas that you'll see, all those tables are under a folder. And then the biggest folder is our build tables. Here, the ones I've underlined are the ones we'll talk more about, mainly control tables and exception tables. And the ones that are in bold, if you can see the difference, these are the folders that exist, but don't have anything in. They're really placeholders. Eve is let's say, a living and breathing document. We're on version 2 at the moment. That is not it. As we continue and develop new features in our advanced spreadsheet, we will add things to it. So just so you can see here, we've got the folder structure. I don't know how useful it is. I'm sorry, this is very blurry, but you can just see that at the top. We've got developer instructions, we've got display pages, our canvases, our user tables, and all the build tables down here. Now, one thing you will notice when you look at Eve is everything is kind of on a canvas now, and that is something that we recommend that people do going forward. Obviously, every time I say we recommend, I hate to quote Pirates of the Caribbean here, but this is a guideline. This is not a steadfast rule. If you don't want to use canvases, you don't have to. We recommend you use them because we find it gives you a lot of control over how things are displayed. So Eve displays everything on canvases, and this is our recommended style guide. Canvases give us greater control over how things are displayed. Our tables are displayed without default lines. Everything is shaded in. We hide the filter dimension. We've got sal indicators on so that you know where you need to fill things in. Tables are also snapped together. I am not a fan of the multiple scroll bars. I know not a lot of people are because it gets confusing. So now as tables expand dynamically, they move for each other and they make room for each other. And that's what the snap feature has allowed us to do. We also have an updated color scheme. Again, it's not super clear here, but anything that is calculated, so populated by a formula, will be shown as a blue field. Anything that is user entry but not mandatory will be gray. Anything that is mandatory but empty will be yellow, and anything that is mandatory and populated will be light gray with a bold text bit, just so you can see the difference between mandatory and non-mandatory fields when everything is populated. Now, exceptions are the thing where we've made quite a lot of changes. We wanted to make it easier because I know exceptions, we had 3 tables for each user-facing table, and it took a lot of work to build all of those. We've gone from 3 tables to 1 table per user-facing table, and instead of recommending that you build exception tables for everything, now we say it should only be tables that do actually flag exceptions, so you don't need to put it in the background just in case. Eve comes with a lot of preset exceptions, especially on the inventory tables, and it's also got the exception functionality all built in. So when you add user-facing tables and you want to add an exception table to that, you just need to make the actual exception table and everything else will be plugged in for you. We've also got a blank exception template, which makes creation of new exception tables really easy. You copy and paste it in, all the formulas are already there, they're just commented out, and it gives you a lot of guidance of how to build it. Now, I'll be honest, I'm not going to say it's really, really easy to build them. It takes a bit of time to get used to, as anything does. We've got a lot of exception tables already in the Eve template. You can look at those, you can make it backwards compatible. You can check what we've done before and try and use that as a guide to what to do next. Exceptions are also now raised on specific actions. A lot of our exceptions are currently flagging things that are out of date. So if you've got a calibration date that's expired or a maintenance date that's expired or something that is just out of date, that will flag it specifically with a piece of text that will say calibration date out of range. We can also map your exception to a specific point in time and a specific user who raised that exception. One good thing about this is all of our exceptions now funnel into our study dashboard apps. So for bioprocess and bioanalysis, we've got study dashboard apps that will combine all those exceptions that have been flagged in specific workflows and will display all of them to you. So you can see if, I don't know, one person always raises the same exception on Friday afternoon, maybe that's a problem that you need to look into. Maybe there's a training issue, or maybe it's the workflow. But it gives you greater control to see what is happening within your workflows. So all of our exceptions, as you can see here, they come with specific strings of text. These are editable if the text doesn't suit your needs, or if you want to add additional exceptions that may be flagged somewhere in your process, you can type in what you need the text to be, and this is what the user will see. We still have exception categories if you need those, and we can also register exceptions, or they can just be gentle reminders to the user. So if you, for example, this first one, retrieve inventory, that is not a steadfast exception. That is just a prompt to remind the user, hey, you've put in an item ID, but you never pulled the information from inventory. It's just a little prompt to help you. So we can say that these exceptions are registered and serious exceptions, or they're just little reminders for the user. Here, our exception table for the equipment table, you can see that it is split into 4 rules. Each rule is a different exception that can be triggered within the table, sorry. So that is retrieve inventory and check status. These are not registered exceptions, they're just little prompts for the user. But down here, past calibration date and past maintenance dates, these are serious exceptions that trigger when the thing that you're using is out of date. And here, this is the exception summary table, just as the designer will see it. So we've got the location, the link, the object that it's linked to. And all of this information is then pushed to those apps that we've got that link up to all of our exemplars now. Control tables are something we've also changed. We've made not so drastic changes to these tables because they still function quite well. Now they focus on tracking incomplete mandatory fields and controlling when you can see exceptions that are flagged. Our new build guide reminds that you don't have to create those 2 tables for every single user table. You can just create one if you need it. If you don't have dynamically expanding tables, one control table will be fine for that. We also have blank control table templates, so you can copy and paste it into your area, so you don't have to make the actual structure of the table. It's already built there for you. You just need to update it. Control tables are also now grouped in folders per user-facing table. This is somewhat divisive. Not everyone likes it. I like it because it means that for every user-facing table, you've got a little folder with the control tables in, and it's all nice and neat and organized. So here you can just see an example. On this side, we've got C1, which is the basic control table, which just controls, what fields are visible and what fields aren't. And here in C2, we've got a few more formulas that will control how the table is displayed as it expands dynamically. This is very much just a loose guide. Again, this is not a rule. This is not something you have to do. This is also looking at adding user-facing tables, not the back-end structure. This is how I would recommend that you update things as you're building things within Eve. So first, what I would do is you create the basic tables, create all the tables that you need, the user-facing tables. Think about what you're trying to get your workflow to do. What does a user need to see to be able to do those things? Once the basic structure is built, I like to do what I refer to as the plumbing. I link everything up. I make helper tables. I do the inventory configurations. I make sure that those tables technically work. Technically is doing a lot of heavy lifting there. It works. It will do what you need it to do, but it's not got any formatting on it. We don't recommend that you apply the formatting to the actual build table in the background. The formatting goes on the front end on the canvases. Once all the tables are built, I need to think about how they're displayed. I need to build my canvases to put the tables on, and I need to jig with how they're presented to the user. What order are they shown in? What order do the tabs and the canvases need to go in? With the order decided, we update a table that allows us to see the order of those tables for things like inventory tables and incomplete mandatory tables. That will be the thing that flags to users later on that something is incomplete or something is problematic. We then create the exceptions tables. Again, exception tables only need to be created where needed. Please don't waste your time creating empty exception tables. It's not going to do you any help. Once the exception tables are created, we can create the control tables, and we update mandatory and complete tables. And with all of that created, we can then apply the formatting to the tables on the canvases. We apply the filters, and now we have a workflow that looks more like you expect it to look. Our very final step would be to add the title tables. One nice thing about putting everything in canvases is now we have instructions on the screen as the user is using tables. It means that we can update the instructions really easily, and it will say the things you need it to say for your users to understand it. The right-hand instruction panel is now what we recommend to be used as just an interface for other modules to be usable with the spreadsheet. So if you want to open Inventory Quick Finder, if you want to pull something from Polar Control, that is what the right-hand inventory panel is, instruction panel is used for. Our final things here, these are recommendations I would have if you're building a spreadsheet. Have a look at the permissions, because if you have an issue, it's going to be a permissions issue, it's very likely. Always look at your inventory reconciliation table, make sure that's updated. Check your transform tables, because although Eve does contain basic data transforms, if you want something specific, I would then build it at the end. And also check your display pages. I know not everyone uses display pages, but it really is a very useful way to show users what's in a workflow. That is all I've got for you today. I hope you've learned a bit about the front-end nature of our Eve workflow. I'm now going to hand over to my colleague Matthew, who's going to take you through some more interesting stuff about how you structure data in the back end.
Cool. Thank you, Sylvia. Cool. Yeah, so as Sylvia said, I'm going to sort of build on what she's just told you about the Eve template and talk a little bit more about sort of the high-level concepts that we try to keep in mind when we're designing a new accelerator. So the main things are easy updates. So we know from experience that when you build a spreadsheet, it's never really done. Someone will come as soon as you've done the first version and they'll say, oh, I just have this one requirement that I forgot to mention earlier. The science will change. New functionality will be introduced that you want to include. You know, the UI may just need a refresh after a few years. So in order to stand the test of time, a spreadsheet needs to be easy to understand, it needs to be easy to fix, and easy to update and maintain. So that's how we're trying to build things. That's how the Eve template was built. So what actually makes a spreadsheet easy to update? And for me, this is about articulating some of the things that I wasn't really taught when I started doing spreadsheet development, but they're common concepts in like software development, for example. So consistency is a big one, and you can see that in the Eve template, that's been something that we've tried to drill into it, that if you build things in a consistent way, then any spreadsheet developer can pick up any spreadsheet, and they'll know more or less what they need to do. Simplicity is using a line that I've stolen here from the Zen of Python. Simple is better than complex, and complex is better than complicated. And all that's trying to say is that if you can keep things simple, obviously you should. And if you need to make something complex because that's the user requirement, then you should come up with a framework. You should make it rules-based. You should make it consistent. And that prevents it from becoming a complicated, tangled mess. The third one here is abstraction. So this is just the idea of hiding details that are not necessary. So the user, for example, in a software application doesn't need to see anything to do with how data is read and written to a database, for example. They just need to know, they just need to see the data, and they just need to know what they need to provide in order to get the output that they need. So it's about building up those layers of abstraction, and you can think about that in the, well, I'll show you some examples of that in a moment. Coupling is a measure of sort of the interconnectedness of different parts of your spreadsheet. So if something is tightly coupled, you can imagine that if you update one component, another component might break, which is not great because you don't want to have to do those parallel updates. You don't want to have to do everything at the same time. You want to be able to phase it out, and you want to know that you're not going to break things downstream when you make an update. And then single responsibility. So this is a principle that essentially says that a component in your software application or in your spreadsheet should only be responsible for one thing. And you can see that in the Eve template really clearly, that we have exception tables and we have inventory query tables and control tables. And each of those things just does the thing that they are built to do. They just handle exceptions or control or inventory queries. Cool. So how do you actually go about applying these? And what I've got here is just a very, very simple sort of diagram that I would draw whenever I start a new spreadsheet. So in this case, we've gone with preparative chromatography, and this is very high level. There are lots of details that I've left out, but this is the kind of thing that I would produce. So what I'm trying to show here with this diagram is essentially the types or the classes that you would have in your spreadsheet. So you've got a spreadsheet, you've always got one of those because that's what you're building. You have starting materials. In the case of preparative chromatography, you might have one or more. Those starting materials go into one starting material pool, which is your feedstock. That feedstock gets broken into fractions. The fractions can go into many samples, and multiple fractions can go into multiple fraction pools. So you don't really need to know about the chromatography of it all. That isn't really the point. The point is that before you start building the spreadsheet, you go in and you actually think about what the data model of that spreadsheet is going to be. Because a lot of the time, it's very easy to get hung up on the the user tables and what those are going to be. It's very easy to get hung up on the integrations, the inventory queries, the request, the BRD, stuff like that. But actually, the most important thing is to think about your safe space within the spreadsheet as a developer. You have a data model that you control that doesn't have any of those external dependencies, and you can just stay in there, you can stay in there, and if somebody comes in and says, I've got this new requirement that you didn't think about, that might change the user tables, but it doesn't change your core data model of the spreadsheet. And this is just kind of illustrating that same idea. So when you're building a spreadsheet, and this goes into like abstraction and single responsibility, you could have a file import going to a user table, for example. And I mean, actually, you could just have a file import, right? So you, in the simplest spreadsheet possible, you could import your data from a CSV into a file import, and you could just show that table to the user. But you then run into problems if you want to update that spreadsheet, because if you need to update the file import, then that breaks what the user sees. If you need to update what the user sees, then that breaks the file import. So you want to have these things split out. So what we would normally do is we would have like a user table, and we would have a file import table, and we would put all the formatting and permissions and parsing on the user table. But you can actually go one further than that, and you can ensure that you always have helper tables in the middle. Where's the button? There it is. You can always have helper tables in the middle, and that's where all your logic and your parsing lives. So if you need to update the user table, you don't have to break anything in the middle here. So for me, I'm going to switch on because it's a heavy mic. For me, my user tables are always super simple. The formulae on there are always things like name equals h fractions name, and I never go more complicated than that on a user table, because what I want to do if somebody comes and tells me they need to update the user tables, I'm just going to delete that user table, I'm going to create a new one. It doesn't matter, it doesn't affect anything in my data model, because if you don't put complicated formulae on the user tables, there's no knock on, there's no dependencies. And another example here that I've put is a unicorn import. So this is something that actually Bryce and Kayla are going to be talking about later on in more detail, so I won't go into too much. But you can do things like for a file import. Actually, I'll come on to this later. Hold that thought. Right, so what other problems can this solve? So as Sylvia said, spreadsheet building can be repetitive. You build the same tables in a lot of spreadsheets. Building the same tables multiple times can lead to inconsistencies, and big spreadsheets with lots of functionality are very difficult to maintain. So we want to avoid those problems. So we come on to modular spreadsheets. And if any of you were in Nick's presentation yesterday, I think most of you were, I see him at the back, hello, you'll know that modular spreadsheets and modular workflow is very much on our mind here at IDBS. We've heard that this is a problem that people are trying to deal with, that they've got these big spreadsheets, and it would be a lot easier if they could split those out and make them more flexible. So we're trying to deal with that in two ways. Obviously, we're dealing with the next-gen modular workflows that Nick showed yesterday, and we're also trying to build more modular spreadsheets into our solutions, into our accelerators. And for that, we're using SmartFill, which I think is probably the most underutilized functionality. It really provides a lot of value, and I think modular spreadsheets are really, really powerful, so that's what I'm talking about today. So why is this useful? So flexibility. This is essentially the ability to switch which functionality you're using on the fly. You don't necessarily need to build everything into a spreadsheet ahead of time. You can have little components that you plug and play together, and so that gives you more flexibility. So for example, I'll talk about a chromatography example. If you do a file import in one format, if you have a file import in another format, you can just pick whichever modular spreadsheet you want to use on the day, rather than having to build both of those into one spreadsheet and then merge all that data in the spreadsheet through logic. It's all very complicated, and we don't like that. Encapsulation is the next point. So this is about putting all of the logic and functionality into one place, into one spreadsheet, and keeping it separate from all your other functionality in your other spreadsheets. So if you have your main workflow, say your chromatography workflow, and then you have a separate modular spreadsheet which does all the integration logic, then if you need to update the integration, you can do that, and it doesn't affect your main spreadsheet. So, and that's really useful for like testing and validation. You don't want to have to retest your entire chromatography spreadsheet just because you updated the file format that you're importing. So by having those things separate, by encapsulating those things in different spreadsheets, you don't need to repeat all that testing. It also helps with future proofing. So again, going back to the chromatography example, when we built our first version of the Insight app in December, we used a file import from Unicorn, and we're now using our OPC integration. So this is an example where instead of having to go into our chromatography spreadsheet and remove all those tables or add in the new OPC tables and then merge that data, we can just build a new modular spreadsheet which does the OPC integration without having to update anything in the chromatography spreadsheet at all, because the format of the data that you're moving between those two is always the same. And then simplification is the last point. So this is essentially just saying that if you have smaller spreadsheets with more targeted functionality, then they can be simpler, right? You don't need to have lots of different options. And the example I've used for this is pick and mix people. I don't know if anybody else ever played. I hope other people played this as a child. Otherwise, this is like a weird fever dream for me. But the idea is that you have heads and bodies and feet, and you can mix those up however you like, and you can get a different combination, right? So here we have a witch who's a footballer and a scarecrow. And this actually kind of helps me to visualize the limitations of smart fill and where it's beneficial and where it shouldn't be used. So as Nick alluded to yesterday, smart fill doesn't really do loops. So if you have spreadsheet A updating spreadsheet B and then spreadsheet B updating spreadsheet A, you end up in a loop. You have an Ouroboros, it's a snake eating its own tail, it's terrible, it doesn't work. But what you can do is have this kind of sequential, linear, modular approach where you have data in, steps in the middle, and then data out, which I've illustrated this way. So you can imagine data in being any kind of integration that you might have. It might be a user entering values, it might be a result query or an inventory query or a data link, whatever you want to do. Your process steps in the middle are your user input. That's your actual process that you're carrying out, so the chromatography steps in this case. And then the data out is going to be wherever you want to send that data again. And if you imagine those as three separate spreadsheets, then you can imagine having one spreadsheet for a file import that goes in a standard format into the user input, and then that goes on to whatever you're using to write your data at the end. And here I've got some more specific examples of this. So you can imagine an inventory query. Now, right now, inventory is built into all of our workflow accelerators. But if you had a custom integration to a LIMS system, for example, to bring your samples in from there, if you had Mosaic or something like that, or if you wanted to give people the option to enter things manually, then right now you would have to build that extra functionality into our workflows. You would have to merge all that data in the spreadsheet. It's very complicated. So you could instead just have a little spreadsheet at the beginning which does all the inventory stuff, swap that out with something that does your LIMS integration, and then you can go either way, it doesn't matter. And then the other two bits are the same because, again, encapsulation, you don't need to update these bits if you update the first bit. And another example, I'm going to talk about Unicorn chromatography again. Unicorn has multiple file formats. There are like 3 different file formats that you can export from chromatography at least. There's web services, there's OPC. You don't want to have to put all of those into your workflow, especially for us because we don't know what customers are going to use. So we don't want to have to build all of that into our chromatography workflow and make it needlessly complicated. So if we have 6 different integration spreadsheets instead that just sit on top of that chromatography spreadsheet, it makes things a lot easier for us and for you. Cool. And then this is the last thing that I'm going to talk about in slides before I go to a little live demo. And this is a data model that we're using a lot more to enhance this flexibility. And these are just quick mock-ups. These aren't from any actual workflow. So, forgive like my missing degrees symbol and stuff like that. But switching arm again, we're talking about entity attribute value. So the traditional way of doing like data models in a spreadsheet, the way that we would typically do it with the results database is that we would have a column per property that we're trying to capture, for example. And then each row on that table represents an entity. So in this case, the entity is the combination of the culture and the date time. So the time point is what we're measuring here. In an EAV model, or a tall and skinny model, you may also hear it called because it has no columns, but lots of rows. We have all of the attributes as rows on that table with the associated value and the unit. And by doing it this way, we can essentially pass in any list of attributes that we want. So again, we as IDBS building a spreadsheet, we don't know what attributes you're going to use. So rather than trying to anticipate all of those, we want to make that flexible for you. So we build it in this model so that whatever attributes you choose to use, they will just work and they'll flow between spreadsheets. If you're using this for Smart Fill, to move data between spreadsheets, you can update one spreadsheet to write a property, and it will immediately be picked up. It will immediately be picked up by any spreadsheets which are consuming that data. That value might not immediately be used in calculations, depending on how you've configured it, but you can at least display that. You can do things like unit conversions generically. Cool. So now I'm going to do a demo quickly. I'm going to show you how we've implemented this in a recent accelerator that we've built. And it's a live demo, so hopefully everything works. Cool. Let me hide that. So just to give you a little bit of background on what I'm going to show, we're talking about a polar control and design of experiment accelerator, which we produced recently. So this is for our new polar control bit of the platform, which is for managing your process. It allows you to capture parameters and the target values for those parameters and the ranges, the acceptable ranges for those parameters, as well as a bunch of other stuff, but that's not quite the focus today. But before I do that, I'm going to launch Spreadsheet Designer over here for the last bit. And that way we won't be waiting for it later on. So I'll do that now. And I might have to re-authenticate because such is life. Cool. So I'll launch this. And we'll just give that a moment. Cool. So this is our new spreadsheet for design of experiment. So the idea here is that we're setting up a study to do DOE on one of our processes. In this case, we're going to talk about bioreactor, but it doesn't matter. It could be any process where you want to manage the parameters and you want to maximize an output. So the main thing is that we have the ability to import information from Polar Control. So I'm going to use this instruction on the right-hand side to open our process locator, and that's going to allow me to browse for a unit operation that we've got saved within Polar Control. So I'm going to select PE Bioreactor 1, and I'm going to import that. And once I've imported that, we can see the data that we've imported. Again, this is not a particularly realistic process, but don't mind that. We've got a list of parameters, and as you can see, this is immediately in that EAV format. So whatever parameters you're bringing in, it adds a new row to the table. It doesn't matter, it's handled generically, so it's very scalable in that way. You've got a target value, you've got limits. We don't need to know too much about this. There's an option for design of experiment, which I'm going to skip today because it's not the focus of the presentation, but the idea is that you can import a study design from one of our Insight apps. And then you can configure a number of runs. So I can enter 10 here, for example. And what this is going to say is that we're going to execute 10 iterations of our run of our bioreactor process in order to and we're going to use slightly different parameters in order to figure out what the best set of values is. And to do that, we might want to assign that to lots of different execution scientists and have them go away and do it in different records. But another thing that we might equally want to do is just do a quick setup of a run and then execution in the same spreadsheet. So by building things flexibly, by using modular principles, we can actually support both of those use cases with the same components. So in this case, what I could do, I could add a couple of ad hoc parameters just to show that. Over here, we've got a catalog linked list. And again, this is what I mean about sort of flexibility. So you don't have to pre-configure everything, like the user can select things dynamically. We can do some manual run updates, and I'll just enter some target values for those numbers there. I don't really know what these should be, so I'm just going to type numbers at random. And you can see that we've got like 10 iterations of this process that we set up. And if I wanted to create a request for each of those, I can do that. So in this case, I'll say we're going to have one request job. I'm going to put down the microphone briefly to type in my name. As the assignee. And then I can, it's rendering strangely. And then I can select that. Control-C. And I'll just paste that down to assign those all to the same job, and I can create the request. And this is the bit that wasn't working last night when I practiced this and got me very worried about my live demo today. But anyway, so we can create those requests, and that will be sent to request. It will be assigned to the user that we've specified, and they'll be able to execute those runs. But if we didn't want to do that and we wanted to just execute it locally, we could equally come out of the spreadsheet and scroll down a little bit to find our run execution spreadsheet. So here we have our run execution demo. This is like, you can imagine that this is a spreadsheet you would have built from Eve. This is like an actual execution workflow. And if we open that, then we'll see that the data, the runs that we just set up in our study designer spreadsheet are automatically populated via SmartFill, and they're ready for us to use. So if I enter, say, 2 bioreactors, and I go to this drop down here, we can see that list of runs that we just set up. So I can select those. And then if I go to limits, we can see for the first bioreactor, we've got those parameters that we just set up. Again, those are just dynamically pulled in. And if we go to the second one, then we've got a different set of parameters set up based on the different options that I selected. But we can also do the request and execution as well. So if I leave that and I go over here, so this is a similar looking experiment where we have a run query spreadsheet at the top, and then below that we have the exact same run execution demo spreadsheet that I just showed you. So in this case, rather than pulling in the information directly from the study designer, we're going to pull it in from the results database using requests to sort of manage the ID for that. And so I can pull in the request information like so, and I'll grab, we can see the one that I just created there, but I haven't version saved the experiment, so that won't work, so I'll use this one that I pre-prepared. And you can see that those IDs are all populated, and we get the link to the job. And then if I go back, I can query that directly into the spreadsheet like so. And we get that. And then all the run details are populated in the spreadsheet here. So we have, a target of 92 for viability there, and then 92 there, and some of these should vary. Oh, I'm looking at the minimum value, 96, and then 92. And then 100, you can see that the values are varied between different runs. And then via the exact same mechanism, using the exact same data model, using the exact same SmartFill tables, things get copied across into the run execution demo. So, so the point is that you can use these modules in a variety of different ways. You can sort of chop and change and recombine them, and that will give you different takes on the same workflow. And so if I go bioreactor 2 and select a run, we can see that in the limits tab. Again, same way. Cool. Cool. So we've got 15 minutes. I've got one more thing that I wanted to show you. So one of the things that we do, I might need to close that. I am going to have to show you Opening Spreadsheet Designer in the end because I forgot to download a file. So one of the things that this brings up is the need to create the same tables in multiple spreadsheets again and again. So that can be very time consuming. Earlier this year, one of the things that we had to do was build a bunch of data studio tables into all of our workflows, and we've got about 60 workflows across the bioanalysis bioprocess solution. So building the same set of tables over and over again is obviously not a good way to feel good about your day-to-day. So to avoid that, we're going to sort of repurpose some functionality in a creative way. This is not really the intended use case of this functionality, but it does work, so why not? So what we're going to do is we're going to use the requesting the rec tables functionality, which you may be familiar with. So if I go into request, if I go to a service and I select that service and I go to the config files, I can download a JSON file which represents the tables that you need to make that integration work. And that's just written in JSON. So you can just change that JSON and it will produce different tables, which is nice if you don't want to recreate all those tables. So if did I launch Spreadsheet Designer? If we launch Spreadsheet Designer, then we can see that in action. So the file that I've just downloaded, this one here, this is the JSON that we wrote to build those Data Studio tables. And you can do this as simple or as complicated as you want. The one that we created has quite a few tables in it, so rather than just creating the DS tables, we created a few additional tables as well. So if I go to Tools and I go to Platform Options, and you can see, oh, everything okay. You can see this is a completely blank spreadsheet. But if I open this configuration file and I go to my downloads, if I can click on my downloads, then I have this file standard dstables.rec tables. And if I open that, then it will say, do you want to create the tables required by the request module to create requests? And I will say yes, and it will build those tables for me. And when I close this, we see those tables appear as if by magic. So this is really helpful because this is a bunch of different tables that I didn't want to create by hand. And if I close that, I can sort of talk through what these are. So Sylvia alluded to this earlier. We have Insight apps now, the BioP and BioA study dashboards, which have dashboards for your exceptions in so that you can see all the exceptions that have been raised in your spreadsheets. And to do that, we had to add DS exceptions tables to all of our spreadsheets. So in order to do that, we followed the process that I just showed you, and that created all these tables here. So the first one is DS records. This is like high-level information about your data studio, about your record. And you can see that we've added not just the fields in the exact naming convention that they need to be to make the data studio integration work, but we've also added these formulae to populate this information from what I've called a class table. We go back and forth on this terminology. It would probably just be called H spreadsheet now if it existed at all. But this is what I'm talking about when I'm talking about that sort of happy place, the internal data model in your spreadsheet. That's what I'm talking about when I talk about class tables. So that's all just being pulled from your spreadsheet table. DS exceptions is similarly coming from your class exceptions table. And this is what I mean about keeping really simple spreadsheets. Anything which interacts with something outside of the spreadsheet, these formulae are always going to be really, really simple in any spreadsheet that I've built. This is about as complicated as it will ever get. Because if I want to change this, I don't want to have to change a load of logic in the spreadsheet. So then class spreadsheet has all the fields that we need for that, and this is where we would put actually complicated spreadsheets, and we can also put comments in here. So these spreadsheets are these formulae are broken when you first import them, but there's a comment there to say this is what you need to do to update them. And we have that for the spreadsheet, we have that for the exceptions, we've got little comments on there to say what the table is broadly. And we've also got things like ID tables. So this is where I've kind of separated things out. Again, that single responsibility principle. So this is a table which just does an auto ID. That's the only purpose for this table. And you can see that we've put like the specific ID that we want to map to in the comment there. And then we have the same ID for the record workflow ID. We have a similar setup for the smart fill table. So if you had a standard way that you were trying to send data between spreadsheets via smart fill, then you could build these tables in this format. And then HText is a standard field for us. It's just where we put anything that we want to avoid hard coding text in loads of different places in the spreadsheet. So we just centralize it on HText. And yeah, so that's the rec tables functionality. That's how we use it. That's all I had for today. I don't know if you had anything more. So thank you very much for your time. If you have any questions, we'd be happy to take those.
Thank you very much, Matt and Sylvia. And we still have 9 minutes for questions. Woohoo! Jennifer, what a surprise.
Oh, Matt, don't go far. So I would love, if possible, to see the Smartsheet table. I didn't think you could pass that much data from one spreadsheet to another through SmartFill. So if you could show the SmartFill table and how you did that, that'd be really cool.
Absolutely.
Thank you.
I mean, if we have a bit of time, you can pass a fair amount of data via SmartFill. Let's see, can I extend this? So which one did you want to see? You want to see the polar control one? Yeah. Let's open up that. And we will just have to, we can all go and get a coffee while spreadsheet design is opening. Yeah, so SmartFill's really good. I'll show you what it looks like in a minute, but it's using the same kind of like tall and skinny approach. So it's lots of rows, but it shows all the data. So if I go to, and you can see that this one wasn't built from Eve, so things are a little bit different while we're still using it. So SmartFill Global, that's just bringing in, that's the entities, right? And then we've got two SmartFill tables in here. So we've got run parameters and run parameter limits. And so the run parameters is bringing in parameters for each. So we've got sort of, you'll see viability multiple times. So we've got multiple viabilities, one for each run. So in this case, we're sort of differentiating between different actual executions of the process. And we have the same properties across multiple, and we have the target value and the unit. And this run ID is like an auto ID that we've generated to ensure that each run is identifiable uniquely across the platform. And then we've also got this index within parent, which is literally just something we use to like order the parameters within the run when we display them. And that runs down like that. So it's actually not all that many rows in the end. I mean, in this case, we only selected a couple of runs, I think. And then for the run parameter limits, so because you can have multiple limits per parameter, so we have an extra nested set of data for that. So we've got action and alert are the two limit types, which are sort of the entities in this case. And then we've also got the run parameter ID. So the entity in this case is the combination of parameter and limit type. And then you've got the upper value, the lower value, and then this is a Boolean field here, which just says, is this the lower limit or not, basically. That's fine. You can talk. I'll be around all day, so you can come and ask. Any other questions?
Thank you. Just around SmartFill, do you have any general tips or guidance on how you would validate templates utilizing SmartFill?
Yes. So the main thing is so when we're testing them, so what I'll normally do is I'll build like an extra spreadsheet, which we're not intending to release, and that will be like my test spreadsheet. So I know what format I'm expecting data to come into that. And I might even put things like cell formatting in there so that if a value comes in that I'm not expecting, then it will highlight, and that way I can have a sort of a test case that I can put through the spreadsheet. So if I have like a specific input, I'll build that as its own spreadsheet so that I can plug that in with a spreadsheet, and then I can test it using that sort of known data set. So if anything, if I've updated a consumer spreadsheet and then I drop in my sort of known test set and it doesn't work, then I can see that. And similarly, if the other way around, then I can have like a known consumer spreadsheet which does something specific and validates that the output is the same for a given input in the main one. So you can build those kind of modular tests as well as the workflows themselves. So that's the only thing that I would highlight there, I think.
Great, thank you.
And then we had a question from Darpner up at the front, but you go. Oh yeah,
Christina first.
Sure.
Yep.
I really liked seeing the feature where you could use the JSON file to automatically create tables. Do you know what version that was added in?
I don't. I know that it's been around for a little while though. So, I mean, I think it was 2019 when we first built our request to spreadsheet, which used that functionality. So I think it's been around since at least then. I don't know the exact version, but a little while. Yeah.
Thanks. I'll have to look into that. I've never seen it before.
Cool.
I'm coming, Darpner. Be ready.
Thanks, Matt and Sylvia. This looks awesome. Oftentimes I get questioned from customers around performance and the amount of data transferring through SmartFill. Would there be any guidance or any advice around the amount of data and any performance impact that you have noticed?
We haven't done upper limit performance testing on SmartFill. What I find is that the limitation with SmartFill actually comes from the number of spreadsheets rather than the amount of data. So I tend to, if you have 9 spreadsheets that are all talking to each other via SmartFill, because those have to be launched and then updated in sequence, you're essentially waiting for the web editor to load 9 times. So that's kind of the performance upper limit that I hit more often than not. I think the actual data, like the data volume, is not something that I've run into yet. And I think that's based on the fact that each of the individual spreadsheets are very small and very simple. Sure. So actually, in some cases, you improve performance because the performance of the individual spreadsheet improves. But yeah, then you have to wait for things to load sometimes, which can be a bit of a pain.
Excellent. Thank you.
No problem.
With the JSON files, my question is, when you import it, does it have to be a brand new spreadsheet that you're importing into, or can you import it into a spreadsheet with hundreds of tables already? You can
import it with hundreds of tables already. So that's what we did with our existing spreadsheets. We just imported that in, and some of the formulae that you've got here was sort of built to integrate with what we already know is the way that we build things in the spreadsheet. So if you know, like, you can put in formulae that will be broken, in a blank spreadsheet. But if you've pre-configured stuff and you know there are going to be fields with a certain name, then you can just import on top of that. There are some limitations, like if you have a scoping dimension that has the same name as another scoping dimension, you'll run into that like variable must be unique error and stuff like that. So you have to bear that in mind. But yeah, you can do it.
It's quite a basic builder question, but Sylvia, you said that you wouldn't suggest putting formatting on the table, you would put it on the canvas. Is that just to prevent the chances of putting formatting on the table and forgetting to update the one on the canvas, or is there something else there?
It's not that it's going to break anything. It's more that because we now don't have the global controls for your filters, so you don't have just a basic on and off switch. It's now a function within the data panel of the modeler. We don't have that global control. So when we have the specific build tables, we keep them free of formatting and free of filters to make it easier to look at, because that's where you're going to do all your updates, and it just makes things simpler. So if you have a big spreadsheet and you've got lots of individual builder tables, you don't want to have to go through each one of those, turn the filters off, take off all the formatting to ensure that you can see everything within it. It's really just a way to improve the way we update tables later on.
Thanks.
Looks like there are no more questions. No? Well then, thank you very much, Sylvia and Matt.